What's up YouTube? Today we're going over the StyleTTS web UI, but first I'm going to give you a demonstration on StyleTTS. To those of you who don't know what StyleTTS is, it's a text-to-speech engine that is really fast but also produces high quality output. So let's just give a couple of demonstrations. So I've got a SpongeBob voice up here. I've also trained a model on SpongeBob, so I'm gonna generate a sample. First generation always takes a little bit of time, but let me regenerate, and this one processes in less than a second. So less than a second for 23 seconds of audio. Let's go ahead and listen to this ReZero line right here.
Obviously, there wasn't a single person sporting black hair or a jersey among those looking at him. Their hair varied extensively: blonde, white, brown, green, blue, and so on. Furthermore, their outfits were armor, dancer's clothes, monotone robes, and more which possessed a certain vibe.
Alright, so that is SpongeBob, and I'm going to load up one more in here, which is Plankton. So there's a little bit of a theme in these voices I'm showing off right now, and I'm going to go ahead and inference with this. Now, I'm going to cut this down just a little bit so the sample is a little bit less long so that we don't have as much to listen to. So here we go.
Obviously, there wasn't a single person sporting black hair or a jersey among those looking at him. Their hair varied extensively: blonde, white, brown, green, blue, and so on.
Alright, so there you go. That is Plankton and SpongeBob in StyleTTS. Now you do notice that there's a little bit of a jarring noise at the end, and that is a little bit of an artifact due to the StyleTTS models not trained on long audio. Now let's go ahead and jump into how you can install this. First things first, the bare minimum requirement is an NVIDIA graphics card with 12 gigabytes of VRAM. Now you might be able to get away with 8 gigabytes of VRAM. I'll talk about that a little bit later, so you might not be out of luck, but that's going to be one of the big requirements for training. Now to get this installed, there are two ways. One, you can be a member at the supporter packages tier on my channel. That'll get you access to this package and all subsequent ones in the future, or you can install it manually. If you want to become a member on my channel, however, you can head on over into my YouTube page or the community tab and then find a link that'll bring you into the members join page. For supporter, it's going to be $4.99. This is going to get you access to things like members only videos and members only lives, which I do plan on making in the next couple of weeks. I think I'll be doing some lives answering questions, and then the supporter packages will get you access to the packages that I'll be releasing. And so at the current moment though, everyone gets access to the StyleTTS package if you're on any of these levels, just for the month of August. So join now before it's too late. But yeah, I'm going to be changing it over into the supporters packages tier in September. So members will get access to this zip file, and all you'll need to do is right click and click extract all. And once that's done, you'll have a folder that is unzipped. So all you need to do is just double click into it, then go into launch webui.bat and give it about 20 to 30 seconds to boot up. So once you see this start to appear, it'll launch automatically in the browser and you'll be good to go. And one more thing is there's this update package.bat that you can use to run through and update the package. So if there's an update, all you need to do is just double click on the updater and then go through these steps. So you'll get these yes, no, all, click A stands for all. And then this last step right here, after these 63 files have been copied, you'll do Y instead. Alright, so with that, you can go ahead and skip to how you can actually use the web UI, but now let's go ahead and jump into the manual installation. Alright, so you're going to want to head over into my GitHub page right here. It's going to be down below in the description, and we're going to follow the instructions here. So manual installation requires that you have Python 3.11, and you need the Git tool, VS Code, NVIDIA graphics card, and Microsoft Build tool. So let's go to Python first. So here is Python. You want to scroll down all the way to the bottom till you find this Windows 64 installer. Click this and it'll download to a location. Go ahead and run that and follow the prompts to get it installed on your computer. There will be a checkbox that says add to path. Make sure you add Python to path when you get there. Then we'll want to install Git on our computer. Navigate into this page, go to downloads, and for this we're going to do Windows. So download the Windows installer and then click this click here to download button. That's going to go ahead and give us the Git installer. So with this one as well, just go ahead and follow through on the instructions. and you can use all of the default options, and that'll get you Git on your computer. And then we need to get Microsoft Build Tools installed on our computer as well. So what we're going to do is navigate into here and follow these instructions on Stack Overflow. So go into Visual Studio, Microsoft C++ Build Tools, download Build Tools. It's going to give you this installer, and then let's go ahead and run it. Click yes. Alrighty, continue through the prompts. And then I don't have Build Tools installed on this computer yet, so that's what we're going to go ahead and set up. So once you see this screen here, you want to go ahead and check this option here. You want to make sure that these are also checked on the right side. We need Build Tools right here. And then I'm also just going to check 2019, 2017, and 2015 Build Tools as well, and go ahead and install this. So this is 12 gigs. It's going to be a hefty download. So let's wait for this to finish up, and I'll be back. Alrighty, so we got Build Tools up and installed, and so that's going to be needed for one of the libraries that is required. I believe it is MFA. Monotonic align. So yeah, that'll fail if you don't have this installed on your computer. So now let's run through the rest of the steps. So navigate to anywhere on your desktop or somewhere that is easy to find, and we're going to start the git clone process. So right click and click open in terminal. So it's going to open up a terminal. Go ahead and type git clone, paste that in here. Oops, so you don't need to type any of that. Just go ahead, paste and git clone. So that'll get this in here. If you're getting an error with git command not found, that means you didn't install git on your computer. So go and recheck that step. So once this is finished, go back into here. We're going to navigate into that repository. So copy this. I'm just going to make this easy by placing terminal on the right and then have the setup instructions on the left. Create a virtual environment for Python 3.11, and then go ahead and activate that virtual environment. Now, if you're running into an issue with activating the virtual environment, it's because you don't have the permissions set for your computer for scripts to run. So what you're going to need to do is go to run as administrator, and you're going to have to say, type capital S E and then a dash, capital E, execution, capital P, policy, and we're going to do capital R, remote, capital S, signed. So set execution policy to remote signed, and then A, yes to all. Go ahead and execute that. And we can now run remote scripts or scripts on our computer. So you should be able to activate this virtual environment. If for whatever reason you're not able to do that, make sure you close out of this terminal and then reopen it back up. So I'm going to type CLS. That's going to clear all of the previous commands. And now let's go ahead and continue. So make sure you've done all of the previous steps. Paste that into the terminal, and we are going to install all of the requirements here. So this is a step where you might run into issues. If you run into any issues, take a look at what it says inside of the stack trace. If it says monotonic align, something went wrong with build tools. If it's something else, you might have to open up an issue on the GitHub page. So that's going to be here on GitHub. All right, next step is we need to uninstall and then reinstall Torch. The reason we need to do this is Torch gets installed by previous packages and will mess things up. So click Y, enter, and we're going to uninstall Torch. And then this next command, just click enter on the keyboard, and we're going to install these wheels. So this is going to be another hefty download, so just wait for this one to finish up. All right, so that is finished up. Now go ahead and copy the next one, paste anyway into the terminal. So this is going to initialize the submodules for the GitHub package, and then we'll install StyleTTS as a library in here as well. So this is going to finish up, and now what we need to do is download the pre-trained Hugging Face models and there are two files here, this .pth and YAML. So we're going to download the epochs and then the YAML. And so those are going to, while those download, we're going to head on over to the next step, which is installing eSpeakNG onto your computer. So head on over into this GitHub page right here. In releases, we're going to scroll down all the way to this MSI x64 file and download this guy. So we've got them all downloaded here. So let's go ahead and complete the previous step though. So that is going to be the StyleTTS1. So I'm going to navigate into the folder where we have them. which is epoch, and then YAML. And let's cut and paste those into deleted WebUI. And you're going to navigate into the WebUI folder, go into models, go into pre-train base, and then paste those into here. And then we are good to head to the next step. So let's head back on over into eSpeak, and we've got that MSI file. Now we're going to go ahead and install that. So next, accept terms, next, install. Yes. All right, and then finish. Now, some people did run into issues installing eSpeak, which they were able to get resolved. So I've referenced this inside of the installation, but if that install doesn't work for you, just try this out right here. And you want to make sure it's inside of your system variable so that it can be found on the system. So after we've got eSpeak installed in our computer, we want to run this download punct script. So copy it, head back on over into the terminal window, go ahead and paste it, enter, and let that install. So here we go. And then now what we want to do is run the WebUI. Everything has been installed, but I'm going to show how you can make this optional batch file so that you don't have to activate the virtual environment every single time. And let's go and create that. So head on over into your StyleTTS WebUI folder. We're going to go and create that batch script. Right click, new, go to text document, and we're going to call this, let's call it launch WebUI. And then we're going to say .bat. So delete that .text at the end. If, for whatever reason, you are not able to see the extensions, we want to see the extensions so that we can get rid of that .text. So go into these three dots right here, go into options, go inside of view, and then uncheck this hide extensions for known file types. And that should allow you to see the extension at the end of the files, which is this .bat. So there's nothing in there right now, but we're going to change that. So right click it, go into edit, and it's going to open in Notepad. So all we need to do is copy these lines into this batch script here. So let's paste that, file save, close out of that, and we have now our batch script. So if everything went smoothly, we can double click the launch web bat. It's going to activate our virtual environment, and then it's going to do that Python WebUI call, and it'll launch up. So moment of truth is soon. All right, so looks like everything booted up without issue, and we are here. So here we are inside of the WebUI. Everything has been successfully installed, and now I'm going to show how we can actually use this web interface. So just a quick overview. There are three tabs here. We've got generation, training, and then settings. Training is what we are going to run into first. Later on, I'll show you how you can set this generation tab up. So, all right, so training, we are going to train the model with some type of speaker. I recommend that you find some type of video or some type of audio of a single speaker. Make sure there aren't mixed speakers for this. We just want a single speaker, and we are going to train with that. To get this all set up, we need to navigate into our StyleTTS folder where we need to get some data. So I actually have a file on my desktop, which is Patrick, and I'm going to copy that and then go into the StyleTTS WebUI folder, go into datasets, right click, create new, and I'm going to call this the name of the speaker that I want, in this case, Patrick. And then I'm going to paste. So we've got this voice in here, and normally when you click dataset source, it'll drop down, but you can't see it right now because we just put it in there and we had already loaded the WebUI. So you need to go into generation tab and click update voices, and this is going to update this dataset source drop-down menu where we can select Patrick. So we're going to select Patrick. Now, processes to use, just leave this at default, chunk size default, English default. So leave all of those at default. If you want to run a smaller Whisper model, you are free to do so. But in this case, I'm going to run with large V3 by default. And this keep original audios file, I normally keep checked because what happens is if you don't have it checked, this original file will get deleted. Well, actually, in this case, I'm just going to delete it. So I'm going to uncheck that, and then I'm going to leave the rest of these the same. Now, rename audio files is going to rename the base name into something more generic. So I usually leave this just in case you have anything that is not UTF-8 friendly inside of the file names. So all of that is good to go. And then we are going to run transcribe and process. But there's one more thing that I want to show inside of advanced settings, and that is disable if dataset files are less than 20 seconds. So if for whatever reason inside of your dataset file you have a bunch of small snippets that you want to instead transcribe, then what you want to do is you want to turn off if dataset files are less than 20 seconds. You want to disable this, because what's going to happen is if you have this checked and you try to transcribe with all those tiny files, it's going to take a long time just because of the backend on how these things work. So just trust me there. Now we're going to run transcribe and process, and it's going to run through the process. So open up the terminal, and we're going to see that additional things are going to be downloaded. In this case, we're going to be downloading Whisper 3 Large. Now, if you have the package version, this won't actually occur for you because I've already put that inside of the folder. But if you're wondering where this is downloaded, it's in this Whisper_models folder, and it's downloading to this Whisper Large v3 folder. All right, and once it's done in the terminal, you'll get a transcription and processing completed successfully down in the console. Next, we're going to run phonemization. So click that button, and this one's going to take a little bit of time as well. Alrighty, so we are done with preparing the dataset. Now the transcribe and process button, if we try to run it again, we're actually going to get an error where it's going to say archive existing dataset. So here we go, top right corner. So this is where you would archive the existing dataset if you wanted to regenerate the dataset. That's just to prevent any file overwriting, etc., etc. So next, we're going to head into generate configuration, and we click this refresh available button. Now in the drop down menu, you'll have the voice name. So in this case, we got Patrick. Now for the defaults here, I have the default set for my 4090, which most devices aren't going to be able to run. So right now I'm running on a 3060 12GB, and I'm going to set it according to that. So for save frequency, I'm going to set it to 1, log interval leave at 10, epochs I'm going to save, let's say for this training video, I'm just going to do 5 epochs, but you can go higher, however many epochs you want to set. But I'm going to do 5 here. Now for batch size, I'm going to lower it to 1 because I have 12GB of VRAM. And for max length, in this case, I'm going to put it at 200. So all of these other things you can leave. And that should be it for our configuration. And we're going to click on update configuration here. So configuration updated successfully in the console. And now let's head on over to run training, and we'll be ready to start our training session. So refresh available to get the voice name here, and we can start training. So go ahead and click start training, open up the terminal, and we'll wait for it to populate a little bit. What I want to now do is open up Task Manager and go into Task Manager, go into this bar, go to Performance, and we want to navigate into our GPU. So right now I've got 3.7 gigabytes being used for my GPU memory, and you're going to see it go up when training begins. So this is very important to notice so we can kind of understand what's happening here. So my dedicated GPU memory is maxed out with 11.8 out of 12 being used. So that means my GPU is what I would call saturated, and I am getting optimal performance on my GPU. However, this ends up becoming an issue. You don't want that at the beginning of training, because what's going to happen is GPU memory is going to continue building up little by little, and eventually you'll end up with data inside of the shared GPU memory. Now, if you're going to sleep, you can actually just leave this, but I'm going to cancel this training session and actually start with a lower max length so that I don't have anything that's overflowing onto my shared GPU memory or my CPU RAM. So I'm going to minimize that. And to cancel training, unfortunately, we're just going to close the window. That is what I have set up for now. And yeah, you'll see that it's now empty inside of dedicated GPU memory. And let's go ahead and relaunch. So close out of that Graudio window, a new one's going to pop up. And let's head back on over into training and generate configuration. So I'm going to refresh the available. Here we go, Patrick, and reset these values. So 1, 5 epochs is what we want. Batch size of 1, max length. In this case, I'm going to lower it down to 150 so that we don't end up getting that. And so the reason that the GPU ends up getting filled more as we train more is because we're training the diffusion model and then the speech language model as well, because these are set to 0. So if we wanted to not have that occur, we could set this to a number that is higher than epochs, and this would lower the VRAM usage overall. However, in this case, I'm just going to leave them at 0, as these actually improve the output of the model quite significantly and update configuration. So let's go ahead, go back to run training, refresh available Patrick, start training, and get this going. Okay, so once again, we are opened up in the task manager GPU, looking at the dedicated memory. The objective of this is we want to try to keep it all on our dedicated memory. And so as you can see, it's starting up now with 10.6 gigabytes out of 12. So that should give us enough buffer room to where it doesn't overflow onto the CPU RAM. And if it does, this is the stage where you would continue lowering that max length until you see that it doesn't overflow onto shared GPU memory. And if you actually notice inside the terminal window, these log steps are actually popping up much more frequently than when we had the previous settings set. So I actually have a little bit of debugging and troubleshooting down here if you want to go through and read it. I won't be going through all of these at the current moment, but I do plan on updating this as people run into things, so on and so forth. Yeah, if you have 8 gigabytes of VRAM, you are going to have to deal with training on the CPU RAM. I don't think there's anywhere around that, which it clocks in at about 8.5 gigabytes at the lowest settings you can train at. But that's not the end of the world. Just set it, leave it for 24 hours, and come back later when it's done. Now, launch TensorBoard. Let's go ahead and try this feature out. So this is going to launch the TensorBoard to where we can see the status of our training. And so here we go. It's running, and we see all of these graphs here. So the important one that we're going to look at is inside of scalars. So we'd go to scalars, and then we'd make sure that this is checked over here, which is the Patrick Models TensorBoard. And then the graphs that we are looking at is inside of, well, the graphs aren't actually fully updated yet. So let's wait till one epoch is finished, and then I'll go over that real quick. I actually let training finish up here, and let's head back on over into TensorBoard. So we'll go on over into scalars. This is where we're going to see our loss graphs. That's the important ones. If you don't see it, click this restart button in the top right corner. And then on these, we're just gonna click fit domain to data on all of the graphs just to make sure they are indeed in the right position. And then to zoom out, you hold Alt and then you zoom out on like the mouse wheel. So now we can drag it around and take a look at some things. So in general, the values that we're looking for are going to be the ones that are lowest. So for these graphs, I can go ahead and turn smoothing down to 0 so that we can actually take a look at some of these numbers. Just quickly going over what these graphs entail. If I hover over a certain point, I've got the name of the model, and then we want to look at the step. So the step actually relates to the epoch that was completed. So this is epoch number 1. This is the first step. Epoch 2, epoch 3, epoch 4, and then epoch 5 here. And then what we're looking for are the epochs that have the lowest value. That is usually going to entail the best model. So there are some other cases with this. Sometimes if a model is further along inside of the training, it might not sound as good as some that are earlier. There are some little quirks about that, but in general, the lower the better. So looking at this graph, we're most likely going to want to grab 3. So as you can see, 3 has the lowest loss for all of them. And so we're going to now go and try it out. So after training, training complete, you go over into settings, and then you're going to click refresh models available. And so that's going to change what models we can select. And in this case, we said step number 3 had the lowest loss. Now the epochs, they start naming from 0. So we're actually going to select the one that ends in 2 here, but this actually refers to 3. So just take this number, add 1, and that's the step that you saw in relation to the TensorBoard graph. So we're going to select that, and it's going to load, as you can see here. And then there's one additional thing that we need to do for being able to inference with the model, and that is to get a small 2 to 10 second audio segment and use that as a reference audio piece. So go into training and then go into the folder. So this is where all of the training data is actually stored for training your model. And we're going to head into audio and then just sort by size. We're going to grab something that is around 400 kilobytes. So I'm going to grab this 209 wave. Normally you would want to listen to it. So let's take a listen to this sample real quick.
Well, I knew TV was bad for you, but I didn't know it was this bad.
And so sometimes when I listen to it, I want to make sure there's no effects or anything inside of there. A little bit of clipping is okay. So we're going to take that, go back into the StyleTTS WebUI, go into voices, and inside of this voices folder, we need to now create a new name, and that is going to be Patrick. So in this folder, place that audio file, and we should be good to go. So once you have those files in there, we're going to head back into generation. And if you click on voices reference audio, you won't actually get anything yet. So we now need to click update voices, update the voices, and we now have Patrick in here. So reference audio, you can actually put a bunch of reference audios into that folder, and you can select which one you want to use here. By default, it's just going to pick the first one. All right, so here we are, moment of truth. Let's go ahead and click generate. And the first generation always takes a little bit of extra time. So as you can see, it's processing here. It's going to probably take about 10 or so seconds to get going. And so here we go. Here's the output sample. And then once we generate the second time, it's much quicker. So that one came out less than a second. So let's go ahead and take a listen.
Inferencing with this sentence just to make sure things work.
And there we go. We've got Patrick. And so I just want to go over into the GitHub repository and go over some of the fields that you'll see. So I have the description underneath generation or usage generation. If you scroll down to this table, you can get a short description of what these values do inside of the WebUI. But let me just show you that through demonstration. So seed is a randomized number that is assigned to each output. So if you have -1, you're going to get a randomized seed. If you want to have the same output between generations, so if I click generate here and then I click generate one more time, it creates the same output. That's because I have a static seed. Now, if you want that dynamic randomized seed to where the output is a little bit randomized each time, leave it at -1. So for the sake of this, I'm going to put it at 0 so that I can show you what these numbers do down here. So alpha basically makes it further or closer to the reference audio that you provide. The closer to 0, the closer to the reference audio. The further away from 0, the farther away. Anything over 1 or 1 and above might start sounding a little weird. So let's go ahead and demonstrate that real quick. So here is 3.
Inferencing with this sentence just to make sure things work.
And then let's go into 1.
Inferencing with this sentence just to make sure things work.
So as you can see, work sounded kind of weird there. And then let's just jump it all the way up to 2 and take a listen.
Inferencing with this sentence just to make sure things work.
So yeah, as you increase alpha, it gets a little bit farther from the reference speaker. Now, beta kind of changes, I'd say, emotion, prosody, emphasis in the sentence. So 0.7 is a good medium, but let's say, for example, we bring it down to 0. Let's take a listen to this generation.
Inferencing with this sentence just to make sure things work.
So that's a nice reading of the sentence. And then now let's just go ahead and increase this to like 1.3.
Inferencing with this sentence just to make sure things work.
So there you can tell it kind of had a little bit of a extra intonation at the end of the sentence there. And it tends to be a little bit more dramatic with beta. So let's generate it at 2.
Inferencing with this sentence just to make sure things work.
So yeah, you can get some interesting results with beta, but yeah, that kind of changes prosody of the sentence, intonation, stuff like that. Next is diffusion steps. So in terms of the diffusion model, so diffusion works by slowly denoising let's say like a noisy image, just like stable diffusion, and that's what's happening here. So how many steps it's using to denoise the output. And so 30 is actually pretty good. You can get away with 5, 10, but the more that you increase this, generally it makes it a little bit better quality, but at the cost of speed. But I'm gonna put it to 400 generate, and this, let's see, it took about, let's say, like 3 seconds, and I'm on a 3060 right now. So let's take a listen to this.
Inferencing with this sentence just to make sure things work.
So slight difference in quality there, and also the way of speech. And then lastly, embedding scale. Embedding scale is also related to kind of like emotion in my testing. So the higher you have the embedding scale, the higher the reference audio tends to impact the output. So let's go ahead and slap it up to 3 and generate with this.
Inferencing with this sentence just to make sure things work.
And so that kind of sounded like how it did at 1, but in general, that's kind of what I noticed with embedding scale. It kind of makes it a little bit more emotional. And yeah, so that is a rough summary of how this generation tab works, and then the values here. The input text, there is a certain length that you are not able to generate with, and that'll come with an error associated with it. So I'll need to work on something that'll segment this out and then concatenate all of those audio samples in case your sentence is too long. And then also there is one thing with long sentences that you'll notice at the end of sentences, you'll have a weird artifact. So let me go ahead and demonstrate that real quick. So I've got this longer audio sample right here, or this longer text, and I went ahead and regenerated these samples. So let's take a listen to it and focus on the end part of this WAV file.
Obviously, there wasn't a single person sporting black hair or a jersey among those looking at him. Their hair varied extensively, blonde, white, brown, green, blue, and so on. Furthermore, their outfits were armor, dancers' clothes, monotone robes, and more which possessed a certain vibe.
So you can tell at the end, there's kind of a clipping noise that occurs, and my speculation and other speculation is that it's because the pre-trained base model wasn't trained on long enough samples. So when you try to generate an audio sample that is over, let's say like 14 or so seconds at around 20, you get that artifact at the end. That can't really be changed, so try to generate with shorter sentences or try to break things up into single sentences. So in this case, if I just generated for this part and we go and take a listen to this.
Obviously, there wasn't a single person sporting black hair or a jersey among those looking at him.
That sound is no longer present in this generation. So yeah, that's just one other quirk that you might notice. And one more thing I just want to show, you can also change and generate with the pre-trained base here. So the pre-trained base model, in case you want to do zero-shot cloning, will allow you to upload any audio segment into this voices folder and generate with that. Alrighty, so I've gone over a majority of the use cases and actually all the features right now inside of the StyleTTS WebUI. Now I'm going to go over some additional quirks, some things like continuing training, so on and so forth. So let's go ahead and jump into that. So one thing real quick is, how do you update this in case I release something in the future and you don't want to go through the entire installation? Well, what you'll need to do is exit out of the terminal and then go into the folder here, and yeah, make sure it's not running. So you'll open this in terminal, right click open in terminal, and what you'll do is type git pull, and what this will do is it'll download or update the changes that were made inside of the main repository and update your files for that. So that is finished, and we can now launch the WebUI with the batch script that we made earlier. Now, like I showed earlier, if you have the package, you have your own update batch script, so just run that and you'll be good to go. So in this case, I did implement an update that's not present in this WebUI, and so if you take a look at this pre-trained model, it's just a text box, and the next update that I implemented turned that into a drop-down menu. So here we go, it's now a drop-down menu. So you can close out of that other one. So now I'm going to jump into how you can continue training. Say something happens or you wanted to stop training. What you can do is find whatever voice you want to train from. Go to set these settings. So save frequency 1, log interval 10, epochs. Let's say you want to increase the amount of epochs that are done. Let's do 10 instead of 5. batch size 1, and then let's say we want to just run it at max length of 100 instead. The pre-trained base model that we're going to use in this case, let's go ahead and continue from the last one that we finished. We're going to select that. We now need to uncheck this load only params. So this allows you to continue training from whatever epoch you stopped at, and you'll be good to go here. And then lastly, I want to talk about these last two settings, the diffusion epochs and the joint epoch. So you can also train the diffusion model for StyleTTS, and by default, I set it to 0 because it's going to start at the beginning of training. So if you don't want to train the diffusion model inside of StyleTTS, you can increase this to some number that is higher than this epoch value. You might save a little bit on VRAM there and a little bit of speed for training. I think it's worth it because the quality of the output is much better, so 0. And then joint epoch is, I believe, the speech language model, and then the diffusion model. They're trained together with this, and the same thing, you can set this to a number higher than epochs and you won't have this training in there. Now there is a quirk. You can't have joint epoch training with no diffusion training. So if I have this set at 20 and this set at 0, this isn't possible and you'll run into some issues with this. So you want to always have diffusion training if you want to do joint training. If you're not into that, just leave it at the default 0 value and you'll be fine. And then we've got all these set. We're going to update configuration, and this will allow us to continue training. So let's go back into run training, refresh available, pick Patrick, start training. So let's take a look at the console and wait for it to pop up. And now you can see that the training has started from the 5th epoch. So this will allow you to train for longer. One thing that you might notice though is that after this occurs, you might see the tensor board doing some weird stuff, and your graphs may look a little funky. So that's the only caveat with continuing training, but it doesn't change, I think, the output of the model. So that is how you can continue training. And then lastly, if you are running into any issues, you can open up an issue on the issues tab here. So go to issue, new issue. I'll be active on this probably for about a week after this WebUI has been released, but I will probably fall off on activity depending on what I'm working on a week from now to answering some of these questions. So yeah. If you run into anything, feel free to leave something down in here. However, if it is already inside of this troubleshooting section down below, then please reference this troubleshooting section first to make sure your error isn't in there. All right, so that is it for today's StyleTTS WebUI tutorial. I hope you guys find this tool useful and you guys find many cool use cases for it. I do want to implement this into like the audiobook maker. I think that's one tool I'm going to be working on in the near future now to get it up and robust. But yeah, I think for StyleTTS wise, I want to learn how to actually get other languages trained in StyleTTS, so that might be something that I look at. But for now, that is going to be it. Once again, I'd like to thank all the members of my channel. Members of my channel now get some perks like packages, so on and so forth. So that is going to be a cool addition, I think, for you guys. And then once again, if you watch all the way through, very much appreciate it. I'll see you guys later.